TechRoute here again. It's been a long and hot day, but now we're going to look into Rust error handling, and the key issue is not to panic. So let's get into it. And hey, we just love panicking all the time, so we're going to start with panic. So basically, it shouldn't happen, and you should try and avoid it as much as possible. But I'm going to give you a few examples of how you actually can trigger a panic, and the first one will be a compile check. So if we take this simple example, and then we try and build it. And here we can see that it actually, this operation will panic at runtime. So this is a compile time check for a panic condition. But sometimes you don't want that to happen. So then what you can do is you can say, okay, allow unconditional panics. We run this one. As you see now, it builds okay. And when you run it, then it will actually panic. So attempt to divide by 0. And then you can also manually trigger a panic directly in code. So we take that one. Approach just didn't accept. Did not. Yet. You can't reach any other code because now I just put a panic macro in there, and then it's okay. But it's sometimes it's useful to be able to trigger a panic, especially if you're like testing your error handling and stuff. So, and let's have a look at a little bit more code here. So this is a kind of a pirate sharing, loot sharing routine. So you have an amount that has been stolen, and then how many crew members. So the variant that will panic is that if you have no crew and just the captain, and then you don't get any crew share. Well, then I just want to mention the panic is an orderly process exit. That is, the stack is unwound and all allocations are undone prior to main exit. Then you can set this Rust backtrace to be able to see more details about exactly where, to visualize the panic in a bit more useful way. So let's take that one. I set the backtrace, and let's activate this one. Again, save it, and then we'll run it and see what happens. So crash, because there's gonna be no crew shares. We get a division by 0, and then you actually start looking. Okay, where did it? There. 26. Okay, so that's the first code, our own code. And then we go up here and we'll look. Aha, 26. So, okay, so we can see, the crew size was 0, so that's going to cause a panic there. So, anyway, continuing, so catch online, it's not going to be covered here. And then we have an example of a double panic. So, okay, so what happens if the system panics twice? So what happens is that we allocate a resource, and then we panic, and then the system starts unallocating, and it uses the drop function on the resource, and then the drop function actually will then fail. So if we go and look at this one. So here is an option where we can simulate a panic inside the drop function. We activate that one, and we go back here, and then we activate a panic in the main. So this will go okay, and then it'll hit this one, and then it will try and execute the drop, which has an error in it, and then that will also fail. And then we also, to be able to cover that, we have this the trace activated. Now, one of the problems with this is that now you get stack traces for the whole thing. So this is going to be actually I'll just scroll through. Let's say it gets a little bit complicated to understand what happens, but I just wanted to actually show you what will happen if you get a double panic and you have the stack trace enabled. So it's can get a bit messy in trying to diagnose exactly, but you will get the stack traces you need to do the analysis. But it's not necessarily the easiest thing to do. We also have the option to go into the cargo and terminal file and tell it what to do on, like, if you get the first panic. So let's say you don't want these cascading, you don't want this double panic situation because it creates stack traces that are, you actually want to capture only the first panic, and then like retest and then catch the another. So the settings is for the development profile and the release profile. Actually, yes, here I just commented it out, so it's available in the example in my example kit. So moving on to the results, which is actually part of the error handling mechanism. Now this can be disturbing, but for lots of people, but Rust actually does not have exceptions. So you have to deal with error handling with panic and its related functions, and then using the so-called result object. So functions usually return a success result, so it's this OK with some kind of value, or an error result, which is an error object with the error, which can, it's an error type. And there's several ways to capture errors. So catching errors the variables way. So here I added a simple example here. So you parse the number, and then it says that if it's OK, then it prints that. If it's error, then it prints that. And then also I made it so that it actually uses the invalid input, so that you can see how it actually handles it and returns the. And then it uses this match switch mechanism to select what the result value was. And then there's a few like extra expansions on that, so you can say like, was the result okay? It's like a Boolean thing, or is it an error? And then if you want to get the string value from the error, because the error object is an error object, and then you can say result errors at unwrap. And then I made just an example here how it actually does that using the unwrap feature. Yeah, and then I also used the Boolean option, so you can say, okay, the result is okay, where's the result invalid is error in combination with the unwrap, so you can actually get a feeling of how those functionalities work. And I just wanted to point out that there are other result dot feature, and there I think you can just very easily Google what these are, but I'll just give the list here. So you have OK, error, unwrap, or with a fallback, unwrap, or else with a fallback. Yeah. And this is actually can be very interesting. That it will give you the reference. It will extract the borrowing references to the value in the result. So you can either take a clean reference, or you can get a mutable reference. Here is a way of our error type to be omitted in function declarations example. So we jumped up to the definition. So create a type alias for a result type. So you can say this is my result, and it's actually mapped to this, that it has the actual result and then the my error, which is some kind of a error that you've defined. So in this case it's the struct, which only has a string member. And in this case, when you start defining one or more functions, then you can just use the my result. You don't have to continue copying this my error to every single function, which makes it a bit more cleaner, especially if you're making like library type functionality. A couple examples of those, and then printing out errors. And then here we can see like so result invalid is it's a result, an incorrect result. So how do you get, so what you can say is, okay, you have that, and then you take a reference for it, and then you take the error, and then you unwrap that. So this just shows you how you get access to the different parts of the object. Then there was actually, when I was doing this research, I stumbled upon a few things which is typical. I wouldn't say typical, but sometimes appears in Rust, where you actually have some depreciated functionality. So if you take different generations of Rust code and you start looking at it, then you will sometimes be faced with depreciated code, and where it actually is annoying that if you take some older code and then you try and compile it with the latest compiler, then it will actually complain about the it actually, in the newer versions of the compiler, the functionality is no longer implemented. So I just thought I'd mention that in some code you'll see this description property, which doesn't exist anymore. And then this is the way so if you're printing out errors, then that's the formatting you use. So you take the result invalid and then you just take a reference of that, and then you say the formatting. And then there's also another depreciated property method, which is called cause. The method has been replaced with source. So yeah, I don't know. It's a bit depressing, but you have to just deal with these things. I'm not really a big fan of this, that you take you implement the basics, and then you use a certain term, and then you suddenly, just in the middle of everything, you change it to something else, and then you don't even keep the backward compatibility. And then input that will cause a parsing error. So then we can print the top level. So this actually is an error now. You print the top level error, and then you use the source method to find the underlying cause of the error. Now, source doesn't always exist. It depends on yeah, like if you're accessing a file in a file system, then you might have an underlying error, or if you have a network connection running and then you get a connection error, then you might actually get an underlying error. So that's what that source is used for. But in some cases, you actually don't. So for simple like parser functions and stuff, you don't have the there is no source of the error. And then you have something called error chain create, which is a separate functionality. I'm not covering it here. Then we have this propagating errors, which is this question mark. And let's see, we have this example we can enable. So if we go up to the implementation, then we see the error occurred IO error. The system cannot find the file specified. So it actually fails on this one here, on the first one. But here you have this propagation character where you can use, so you don't actually have to write these match statements and the forwarding of the error. So you can just you can fix it just by syntactically simpler fashion. If in this regard you just want to like forward the error. If it fails, then forward the error out of the function of the stack. And then I made an example where you can actually see, so it enters here, and then it's going to call this, and then this one supposed to read to a string, and then it tries to open the file. The file, in this case, the file doesn't exist. You could actually create a file and see what happens if it tries to read the content and it can't parse. And then it basically generates an error here, and then this character will mean that it will take this error and it will pass it through this result object, and then it will come back here, and then it will exit from here because of this, out of this function, and then it will end up coming out of here. Yeah. And then propagating errors when working with multiple error types. This can happen like if you have this functionality I just described above, then it can actually be multiple error types. So you basically only read file to string that propagates this type of error, and then this one here propagates. So all errors are based on this error object, and then this here propagates a boxed error. So it can take you can take all like standard errors and then just box them up and forward them up the chain. And then there's something called error chain create, but that's not, I'll cover that here. Now, in Rust, you can and cannot. There are certain tricks you can do, but basically you can't just do like you can do in lots of languages where you can say, try catch and don't give a crap what fails. In Rust, you have to be a little bit more meticulous on how you protect against errors and how you should handle error conditions. So I tried to throw in a few examples here, and you're gonna have to like think when you're coding your own code, and then you have to reflect on these examples, and then you have to think about, okay, how are you gonna build your system? I mean, I don't think there's a universal way of demonstrating all permutations of error conditions. But here's a few. So So we say, okay, we say digit is red, so that's obviously wrong because it's digits. And then we have a parsing situation here where the parsing will not panic. But then the result is unusable. Unwrap fails on it. And then you can't use this one here because the general result is not a general result, as we are in main. Result is unusable. We can capture it with expect. So here's the example how to use the expect. So none and expect. We have a problem. And there are certain instances where you can use this syntax here to actually ignore an error. Read file and ignore. Let's see. So here, for example, it tends to open a file and to read the file content, and then it does this file map, ignoring the result of the read to string. So basically, read to string might fail, but it actually just says, "Ah, forget about it." So that, as I said, that I really couldn't find a good way to make a universal explanation of all the combinations and permutations where you can actually get errors and how to handle them. But I just thought I'd throw in some of these so you are actually aware that you can actually have hidden errors or silent errors, and yeah, there are some tricky ways to handle it. But that, how to handle them will become with experience and by looking at examples. And then we look at, okay, how do we handle errors in main? And there you have the problem where you can't propagate the error because main hasn't got the return type. You can't define a return type, so it's not possible to use that syntax. Expect is one option where you can say parse my number invalid input, and then you can just terminate it there, and then handle the error and exit just with a standard process exit. And then the last example I have here is to be able to declare custom error types. So that's actually useful for building your own libraries or functionality that you would like to have your own error types. So what I've done now is I've created a my app error in the result structure. And basically I can still use these standard errors that are thrown out by the library function, and I just map them to my own. And then I threw in some custom errors here. Out of range or invalid number. And then I actually added the whole structure here. So this is actually quite a big section. So I suggested you come and you look at this yourself in your own peace and time. But I'll go through the main structure just quickly for the point of this video. But I think that this requires that you sit down and actually look at it. But I think this has all the components you need to build your own a good example of how you build your own custom error types. So we derive from debug, and then I just defined a custom struct. So I defined an out of range error, and it's got just a string in it, and then invalid number, and it's got a string in it. And then I implemented the display trait for the out of range and invalid number. And then we implement the error trait in the struct also, bring that in. And then this derived debug automatically implements the debug trait for the enum. And then we finally get to defining my application error. And in this case, it 3 times. Actually 4. Maybe I had 3 in when I started. Now it's got 4. So basically IO, and that's just a standard error. And then parse is just a integer error. And then out of range is my custom out of range error, and then invalid number is the invalid number. And then I did the implementation for the displayed for the whole of my error. Yeah, and then the error type mapping. So we put the error on my app error, and then we implement the source functionality, and then we do the mapping here inside, so how it maps. And then it's a convention that the custom variance would typically return none, because it does not inherently involve a reference another error. So your custom errors, they stop in your custom function. They don't try and represent some lower level error that has happened. And then it was the function that actually uses the error, so you can see how it actually uses the custom error type. So that was that. Hope you didn't panic too much. There was one piece of literature I was reading that says about Rust errors and error handling. This is nothing too complicated. It would be easy to understand. And when I started digging into it, and it's like, oh yeah, right. Yeah. I don't know how. Personally, I have a little bit of mixed feelings with this. I don't know if it's the. I mean, it works, of course. It's an error handling structure, but yeah, I think they were desperately trying to get rid of this. Or one of the ideological approaches in Rust is we need to get rid of this like global error capturing. They're against that. That you just create, you write 200 lines of code and then you just put a try catch in, and then you can just fail anywhere. So they wanted to at least get a little bit down to a lower, so that you're actually thinking about each and every function, what it does and how it can fail, and that you actually introduce some kind of basic error capturing or error handling logic. And I mean, the question mark is of course also a little bit of compromise to that one. Rust can still panic, so it can still totally crash like any other programming language. So if you don't capture that kind of stuff, then it will fail. Anyway, as I said, hope you didn't panic. I hope you find this useful. I'll be uploading this to my GitHub site with a reference in the comments. You can actually pick up this specific code, and the idea with this code, like in other episodes, is that you can actually take the same example that I've been here, and then you can bring it into your own environment, and then you can play with it and actually compile it and run it and massage it, and then copy these solutions into your own application, whatever you're working on. So it's like a dynamic reference manual, a living reference manual, without being a complete application that's too impossible to understand. Anyway, enjoy, happy hacking, see you in the next one.